Welcome to the Hometime Project Center. I'm Dean Johnson.
And I'm Peggy Knapp. In the video you're about to see, Dean and I will demonstrate on this set how a typical home addition might be wired.
And we'll show you how some of the same procedures are used in an addition under construction.
Hometime is made possible by Chevrolet, who brings you full-size Chevy pickups, the most advanced in Chevy history. Chevy S10 pickups, compact, fun, and hard-working. Chevy S10 Blazer, America's most popular sport utility vehicle. Chevy Astro, the van that can. The heartbeat of America. Today's Chevy truck.
This video is just one in a library of instructional programs designed to assist the viewer in working on a wide range of home improvement projects. And before we begin our program, I want to explain how you can best make use of this educational system. First off, you should watch the tape all the way through to get an idea of the methods, the steps, and the terminology we use. To help familiarize yourself with the terms, we've included a glossary in the project guide. Then you should review the tape again, only this time, check with your project guide to determine the tools and materials appropriate to your project. Then take the project guide to your local building supply dealer or home center. The people there will be able to assist you, answer questions, and direct you to what you need. Electricity is dangerous. Even the smallest electrical project requires careful planning and a thorough understanding of the safety procedures and regulations defined in the electrical code. So, let's take a look at the tools we'll be using.
For electrical work, almost every tool you'll need can be carried in one of these belts. And for the most part, you won't need anything fancy. Most of the tools we'll be using can be found in any well-equipped do-it-yourself workshop. First, we'll need an assortment of pliers, a 7-inch lineman's pliers, an angle cutter, and the needle nose pliers. Next, we'll need some tools to remove the insulation from the cable and the individual wires, like a cable ripper and a wire stripper. And of course, you'll also need your basic do-it-yourself toolkit, a set of good screwdrivers, a hammer, and an electric drill with a spade bit. Here's a handy tool you might consider renting if you are running wire through new construction. This right-angle drill uses an auger bit to put a hole in tight areas where it's hard to reach with an ordinary drill. This device is a polarity tester. It performs some important safety checks and can help detect faults in existing wiring.
Your local home center or hardware store can help you out in your material and tool selection. Again, this is a good time to use your project guide to assist you in selecting all the items you'll need and avoid return trips. You'll find bins of receptacles, switches, wire cable, breakers, switch covers, and switch and receptacle boxes. Shopping for your electrical supplies can be a baffling experience, so we hope to take some of that confusion out of it for you during the upcoming program. So let's go back to the Project Center and get started.
We're going to start by wiring some basic circuits here in the Hometime Project Center to show you what goes into a wiring project. Then we'll show you what might go into wiring a room in a new addition.
Then we'll visit a construction site and apply the same techniques to the wiring in a major remodeling project.
This is the most important safety device in your electrical system, and it's important to know how this panel works. All the electricity in your house runs first through this box called the main service panel. Now, there are many kinds of service panels, but they all serve the same function. So don't worry if yours doesn't look exactly like this one. This is a common service panel that includes the main overcurrent device or main disconnect and all the branch circuit overcurrent devices in one cabinet or box. In this case, each overcurrent device is a circuit breaker, a switch that opens, shutting off the flow of electricity when there's a short circuit, a ground, or when the circuit is overloaded.
These are some common service panels. This one uses a familiar screw-in fuses instead of circuit breakers. The main disconnect is here, and to disconnect it, you pull firmly on the handle, exposing both of these main cartridge fuses. Fuses and circuit breakers are all rated for a specific maximum amperage and are matched to the rating of the wire in the circuit each one protects. This means that when too many appliances are plugged into a circuit of insufficient ampacity, the fuse blows or the circuit breaker opens, instead of the wiring becoming overheated from carrying too much current. So, never replace a fuse or circuit breaker with one that has a higher rating. Even with the main breaker in the off position, which shuts off all the electricity in all the branch circuits in the house, there's still power in the box.
The wires up to the breaker are still hot. So if you're replacing a light fixture or updating a receptacle, remember to turn off the breaker or fuse for the circuit where you'll be working.
Turn it off and test it.
Now the first thing we're going to wire is a simple light fixture and switch.
This is a typical stud wall that you'll find in either new construction or an addition. We'll be installing a light switch here and a light up here. The wiring will enter the box through these openings, and on the side of the box is a gauge to tell me where to position it on the studs so it'll be flush with the finished wall.
We're going to be extending the circuit out from this existing outlet, so we need to drill the holes and route the cable through them. If for some reason you're forced to make a hole closer to the inside edge of a stud or joist, you'll have to use a metal plate on the stud to protect the cable from nails or screws. Common drywall screws are long enough to pierce an improperly routed cable, so you can see why it's important to plan your run of cable so you don't drive a screw or nail into it later when you put on the interior walls. Well, that should do it. Let's pull some cable.
When you run your cable through the framing, try not to make sharp bends or put a kink or twist in the cable. You want to leave plenty of cable at the ends for making connections.
At every box along the run, I'll cut the cable, rip, and remove about 8 inches of sheathing. And then put the wires through the opening in the box to be wired in later. Now, before moving on, I'll staple the cable in place.
Basically, the idea is that whenever you run parallel to the framing, you need to support the cable with staples. Whenever you run perpendicular, the cable is supported by holes in the framing.
Your local building code regulates what materials you can use. We're using NM, or non-metallic sheathed cable. It's often called Romex, the brand name of one of the manufacturers. Commonly used wiring materials in new construction include armored cable, galvanized metal conduit, plastic conduit, and several kinds of NM cable. So you do need to check with your local code. Now, just because we can use Romex here doesn't mean you can in your project.
Here are some individual wires in different sizes. These larger wires are rated up to 200 amps and are used as service entrance wires. This is a piece of number 14 wire, the size used in a 15 amp small appliance and lighting circuits. Individual wires like these run through galvanized metal conduit and other types of raceways. You can see that the larger the wire, the higher the amperage allowed by code. Here are some lengths of cable. Notice how each contains individual wires inside a protective sheathing. Armored cable, or BX cable, is sheathed by a flexible steel jacket. Type UF, or underground feeder cable, is waterproof and used when the cable is to be buried directly in the ground. 14-2 Romex contains only 2 insulated wires and a bare ground wire. This is NM 14-3 Romex. Notice it contains 3 insulated number 14 wires and a bare number 14 ground wire. Both the black and red wire are hot. The white one is neutral. Check with your local building codes to make sure the materials you use are acceptable and safe. Make sure the wire you use is of sufficient ampacity. The NM cable we're using is called 14-2 Romex. This means that it contains 2 14-gauge insulated wires and 1 uninsulated. The size 14 wires in the cable are rated for use in 15 amp lighting and small appliance circuits.
With 14-2 Romex, the white 14-gauge wire is the neutral wire, the black is the hot, and the bare copper is the ground. Now, to be in compliance with code, the intact sheathing should extend into the box a ½ inch. The code requires that at any place along the run of your cable where the insulation is removed to connect a fixture or to make a connection with another wire, it has to be enclosed in an appropriate box. Now, there are two kinds of boxes, metallic and non-metallic, but there are many sizes and shapes available. These boxes are for a single switch or receptacle. This box can hold 2 receptacles or 2 switches. These boxes are for light fixtures and have these joist-mounted brackets for hanging overhead lights. Here's a weatherproof box for an outdoor receptacle. When a box contains only wire connections and no devices, it's called a junction box and must be sealed with a plain cover. I should point out that junction boxes must always be accessible, so you can't cover them up with a wall or ceiling treatment. To comply with code, all boxes must be closed. In the case of a simple switch or receptacle box, the cover plate of the device serves as an acceptable cover. Sometimes it's necessary to use a plastering ring and the cover plate of the device to effect an acceptably sealed box. These blue plastic boxes have lots of information stamped right onto the body of the box. The gauge on the side helps to mount it properly. And inside there's information about how many wires the box can safely contain. The electrical code regulates the size box to be used. Too many wires inside a box that's too small can result in overheating or damaged insulation, and it may cause a short or an unwanted ground when a switch or receptacle is forced into a space that's already crowded with wires. Now, all boxes have knockout shapes molded or machined into the body of the box. Prepare the opening for the cable according to the type of box you use. On these, I use a screwdriver to unhinge the number of openings I'll need. On these, I use the handle of a lineman's pliers. It's easy to poke out a knockout in this kind of plastic box. On this metal box, I poke the knockout loose in the same way and twist it off using the pliers. The knockouts allow for the entry and exit of the cable. Prepare only as many openings as you'll need for the installation. Now, in almost every case, the cable must be supported where it enters the box. In the event that there are no internal clamps on the box, then the cable must be supported by one of these cable clamps. On this metal box, I put the connector through the knockout opening, tighten down the lock ring, feed the cable through the opening, and tighten it down. Some metal boxes have built-in cable clamps, but these lock nut connectors are often used to fix different kinds of cable to the box. When you're adding more wires to an existing box than it's rated for, you can add this box extension.
When the boxes have been mounted and the cable has been pulled through the framing, when the sheathing has been removed and the cable end stuffed into the openings on the boxes, the rough end's complete.
At this point, if we were wired through to a source, the electrical inspector would visit to make sure the installation was in compliance with code. Now, under normal circumstances, the interior walls would be finished before the switches and receptacles were wired. But we're going to go ahead and connect the devices so you can get an idea of how all the elements in the project fit together. Now, we'll start at the end of the run and work our way back toward the source, hooking up the devices as we go. This way, the last connection we wire is to the source.
We'll be installing a simple light fixture. Notice that it has 2 wires coming out of the base, a black wire and a white wire. First, using my wire stripper, I place the wire in the slot marked 14 because this is size 14 wire. In working the tool, being careful not to damage the copper conductor, I remove about 1 inch of insulation from the end of each wire. With the fixture mounting bracket in place, I always start by making the ground connection. Then I make the neutral connection to the white wires, and the last thing I do before securing the device in the box is to make the hot connection. I secure the fixture mounting bracket, and since we're at the end of the run, we only have 1 bare ground wire. I just connect it to the grounding terminal on the mounting bracket. I take the 2 ends of the white wires, and holding them parallel, I take one of these solderless connectors, they're called wire nuts, and screw it on tight. Notice how the skirt of the wire nut covers all the bare wire, so that there's no chance of an accidental short or ground. Wire nuts come in several sizes. The larger ones can connect several smaller size wires or a few larger size wires. Check the box they come in to make sure you use the appropriate size wire nut. The next thing I want to do now is connect the two black wires, again using a wire nut. Now we secure the fixture to the box, and we're done.
To wire the switch, I start with the ground wires. I connect the two ground wires with a wire nut and fold them back into the box out of the way. Now I make the neutral connection. Remember, you never interrupt the run of the white wires with a switch. So I want to connect the two white wires together with a wire nut the same way we did before. This is a single pole switch. It has two screw terminals on the body of the switch. Now be careful not to install these upside down. When properly installed, the side of the toggle marked off is on the top. There are two remaining wires to be connected. The black wires will be connected to the screw terminals on the switch. Now you never connect more than one wire per screw terminal. It's a safety regulation. To make a good safe connection to a screw terminal, I trim the end of the wire to just the right length so that it will make just less than a full turn around the shaft of the screw. I use the needle nose pliers, grabbing the bare wire right at the tip and twisting it into a clockwise hook. You don't want any of the insulated part of the wire to be clamped under the screw head, nor do you want too much bare wire to be exposed. Now I'll just connect up the other black wire to the other screw terminal, and then we'll mount the switch into the box, and then this circuit will be ready to connect up to a source of power.
Here's the live receptacle we'll be tying into. Now there's been no current in the wires we've been working with. You never want to work with hot wires. So before we start working on this receptacle, we'll turn off the breaker on the panel that controls the branch circuit. This is a polarity tester. It can tell me several things about the wiring. In this case, when I plug it in, it tells me this circuit is hot and has been wired correctly. So we need to turn off the circuit before tying into it.
Now here at the service panel, we'll look at the legend to figure out which breaker controls the circuit where we'll be working. And it looks like it's number 10. So we'll turn that off.
Before I start, I want to test the outlet again to make sure it's absolutely safe. This is an end-of-the-run receptacle. Notice how a single white wire is attached to just one of the silver terminals, and the black wire is attached to only one of the brass terminals. Since this is a metal box, the ground wire is attached to both the body of the box and to the receptacle at the green screw terminal. First I prepare an opening in the box, stuff the cable, and clamp it to the box. To make the ground connection, I undo the pigtail and make a new one that includes the new ground wire. Then I fold all the bare wires back into the box. Now I attach the white wire to the empty silver-colored screw terminal. Then I attach the black wire to the empty brass terminal. I remount the receptacle in the box by tightening the mounting screws and replace the cover plate.
You all set there?
All set.
All right, I'm turning the breaker on.
Okay.
Try the light switch.
Let's give it a shot. Works.
A switch is a mechanical device that allows the safe interruption of the flow of current through a circuit. This old-fashioned bayonet switch gives you a good idea of how switches work. When the switch is closed, in the on position, current is able to flow from the source to the load. But when the switch is opened, there's no connection and the flow of current is interrupted. These modern switches do pretty much the same thing, but there are no exposed parts. This switch is the modern equivalent of the old blade switch. This is a single pole switch like we just installed. For comparison, look at this three-way switch. The three-way switch has 3 screw terminals on the body of the switch, while the single pole switch has only 2 screw terminals. Notice also that the single pole switch toggle is marked on and off, while the three-way switch has no markings. The three-way switch is used in a circuit where 2 or more switches control the same load, usually a light fixture, as in an upstairs and downstairs switch for an overhead light above the stairs. These are dimmer switches that allow you to control the brightness of a light by twisting the rheostat like this. Pushing the switch in turns it off or on. And here's a switch with a built-in pilot light that tells you when a light in another room or outside is on. This switch glows in the dark, so you don't have to fumble around to turn on a light. Next, we'll show you how a three-way switch is wired.
Three-way switches are used when more than one switch controls the same light fixture. We're going to show you one strategy for wiring a circuit that includes a light fixture controlled by two switches. I've mounted both of the switch boxes. Notice how the switches are about at the same height, 44 to 48 inches from the floor. And I didn't mount the switch box on the hinge side of the doorway. That way the switch will never be hidden behind the door when it's open.
I'm using a right-angle drill that we rented. It has a 7/8 inch auger bit, and it runs at a low speed, so the bit kind of pulls itself through the wood. Now, this tool is very handy if you need to make holes in the framing in places like this where it's difficult to get good leverage with a regular twist drill.
Between the light fixture box and the switch, we use regular 14-2 Romex.
We're using a length of 14-3 Romex for the run between the two switches. 14-3 contains a red and a black hot conductor. We'll need the extra wire to hook up both sides of the three-way switch. We remove about 1 inch of insulation from each wire. To hook up the light, we connect the fixture to the ground wire. Connect the two white wires with a wire nut. And the two black wires. Then mount the fixture. We connected the ground wires with a wire nut and put them in the box, and then connected the white wires with a wire nut and put them in the box. And now we'll connect the switch. Now I take the black wire from the light and connect it to the common terminal. The black wire that connects to the other switch, I connect to the right side terminal, and the red wire I connect to the left side. Then mount the device in the box.
At the next switch box, I wire nut the bare wires together and fold them into the box out of the way. Then I wire nut the two white wires together. Then I connect the black wire from the source of current to the common terminal.
The black wire to the right side.
And the red wire to the left side.
Then we turn off the power again at the service panel and hook the circuit extension up to the end of the run receptacle the way we did before. But since this time we're tying into a plastic box, the ground connection is handled differently. We need to disconnect the bare wire from the receptacle, and using a piece of scrap wire that I've saved and this green wire nut called a greenie, I make a pigtail, and then connect the pigtail to the green terminal on the receptacle. Then I'll finish the hookup. And the polarity tester tells me everything is in order. Now, you can't always wire a three-way combination like we just did. Often the source comes in at the light fixture, and then it takes a different set of connections to make the circuit work. Next, we'll show you how to wire a switched receptacle.
Let's take a look at the common receptacle. Take a close look at every device you plan on installing, and you'll see that there's a lot of information stamped or printed right on the device. This is a side-wired receptacle. On the yoke and on the body of the switch are the marks that indicate that Underwriters Laboratory has tested and approved this design for its intended use. This marking indicates what kind of wire can be used with this device. Here are the voltage and amperage ratings. This device is approved for up to 15 amps and 125 volts. There are 4 screw terminals on the body of the switch and 1 on the yoke of the switch. These 2 are brass colored and are used to make the hot connection, and these 2 are silver colored and are used to make the neutral connection. This is used to make the connection to the ground. Now this is a 3-hole grounding type receptacle and is required by code for all new construction. Notice how one slot is smaller than the other. The smaller slot is connected to the black or hot wire, and the larger slot is connected to neutral. The U-shaped slot is the connection to ground. And this is the old-fashioned ungrounded 2-prong receptacle that is common only in older wiring. This receptacle has an L-shaped grounding slot. It's rated for up to 30 amps and is used to provide current for a clothes dryer. This receptacle is rated for up to 50 amps and provides current for an electrical range. It's wired with both 120 volts for the timer and lights and 240 volts to deliver current for the range's heating coils. Notice how the slots are angled to prevent anything but a range from being connected. Let's take a look at what goes into wiring a receptacle.
Receptacle boxes are mounted on a wall at a height of between 12 and 18 inches measured from the floor. This run of cable will take power from the existing receptacle to these 2 new receptacles, and this last box will be controlled by a switch.
The electrical code requires adequate lighting for every room in a home. Now the specific provisions vary from room to room, but the basic idea is to provide a switch controlling a light near the entrance to each room so you don't have to enter a dark room looking for a lamp.
This means that when there's no overhead light fixture in a room, you should provide a switched outlet so that you can plug in a lamp and control it from the entrance to the room. We're wiring this run with a switch loop.
We'll start the hookup at the switch box and work our way back along the run toward the source. First I take my angle cutter and snip off the end of the ground wire. Then I attach the 2 remaining screws to the terminal and then mount the switch in the box.
Here at the switched receptacle, I made a pigtail out of the 2 ground wires, a greenie, a piece of bare scrap wire, and then I attached it to the green grounding terminal on the receptacle. Then I took the white wire that leads back to the source and attached it to one of the silver terminals on the body of the receptacle. By the way, if greenies aren't available in your area, pigtailing the ground wires with this method is also acceptable. Then I connect the black wire that runs to the switch to the upper brass-colored screw terminal on the receptacle, and then break out the brass tab that connects these 2 terminals. By breaking out the tab between the 2 brass terminals, the lower receptacle stays hot while giving us control of the upper receptacle at the switch.
Again, as we did before, at the unswitched receptacle, I pigtail the ground wires with a greenie and a piece of bare scrap wire to the yoke on the receptacle. I connect each white wire to one of the silver screw terminals, and then I connect each black wire to one of the brass screw terminals. Many lamps, all televisions, and many other devices come with polarized plugs, so it's important to always hook the black wires to the hot side of the receptacle. Now we're ready to mount the receptacle and move on to make the source connection.
Don't assume anything when it comes to safety. Test it, and test it again to make sure there's no danger of getting a shock. Just as before, we connect to ground by redoing the pigtail and adding a wire. The new white wire is attached to the silver terminal, the new black wire to the other brass terminal. We remount the receptacle in the box, add the cover plates all around, and we're ready to give it a try. You ready to try it?
Get it in here. Okay, give it a try.
All right.
Works.
Great.
When When you're running errands for supplies and moving appliances, you need plenty of room, as well as comfort. A Chevy Astrovan delivers both.
Well, just look at all the room inside. Up to 151 cubic feet of cargo space with the rear seats removed. Plenty of room for long pipes, bulky fixtures.
Whatever you need to get the job done. And with Astro's large swing-out rear doors, you can get the material in and out real fast.
The same with this easy open sliding side door. Equally handy for loading cargo or letting passengers aboard.
Speaking of passengers,
Yes?
did you know Astro will hold up to 8 adults in roomy stretch-out comfort?
I knew that. All you have to do is replace the standard middle seat and the optional rear seat. And that is a snap.
And look at the seating versatility. You can turn the second bench around to face the optional third bench, or you can fold them both down to make a flat load surface.
Well, you know, Astro wouldn't be the van that can if it didn't have the power to move all that cargo and all those passengers.
Okay, Peggy, how powerful is it?
Plenty powerful. In fact, the standard Vortec V6 is the biggest engine available in a new-size van. And when properly equipped, Astro can tow up to 6,000 pounds, including passengers, cargo, and trailer.
And another thing, with all its power and room, Astro's still compact enough to fit in a family garage.
All of which explains why they call Astro the van that can.
You know what else they say? Nothing works like a Chevy truck.
I knew that too. Wiring a project like this can be broken down into 3 stages: the planning, the rough-in, and the finishing. Now, we've shown you the techniques involved in the installation, so let's take a look now at what goes into the planning.
Starting with this floor plan of the upstairs, we can locate the existing circuits and then sketch in the additional switches and receptacles we want to add to the plan. For the kitchen and adjoining dining area, code requires 2 20-amp circuits be installed to handle the various appliances. How many circuits are required will be determined by the number of appliances that you're wiring for. If you're in doubt, call your local building department for clarification of the local code.
General code requirements are that you have one 15-amp circuit for every 585 square feet of living space. Now, that's the minimum to ensure safety. We recommend you provide 1 branch circuit for every 500 square feet to give you a more flexible installation. We identified the 2 existing 15-amp circuits that currently supply power to the overhead lights and wall receptacles here in the basement. And by planning for the use of each room, we'll mark for the additional switches and receptacles that we want to add. Here in the closet, we'll add an overhead light, a wall switch here. This is an existing outlet, so we'll put an outlet here, here, and another here.
Let's take a look at our service box to see what additional circuits it might handle. Now, as we said, service panels come in various shapes and sizes. This one is a 200-amp panel. As you can see, there's plenty of additional space for extra circuit breakers. If you're planning a remodeling project and have anything less than 100-amp service, you may have to consider installing a new panel and then contacting a licensed bonded electrician or local power company to arrange for a new service drop. On the inside of the service panel door is the index telling you what areas are controlled by each existing branch circuit. If your panel isn't indexed, do it now. You can't plan your new wiring if you don't know what your existing wiring does. Now let's turn off the main power supply and look inside the panel. The main feeder line from the meter enters at the box, and its neutral line is wired into the bus bar. And the hot wires connected to the main breaker feed to the main bus bars A and B. And finally, the panel box itself is grounded from this end of the bus bar to the cold water feed in the house, with an auxiliary ground in the form of a grounding rod driven into the soil outside the foundation.
Before any work can begin on the project itself, you'll want to visit your local building department and get the required permits. And while you're there, take advantage of their expertise and review your design plans with them. Once you've obtained the permit, you can go to work. First, we want to transfer from our plan the locations of all the new wall casings for switches, receptacles, and fixtures right onto the framework. Code requires that you have an outlet 6 feet from a door opening and every 12 feet thereafter. Now, the reasoning behind this is that lamps come with a 6-foot cord. So theoretically, if you set up the room this way, you won't have to use any extension cords because you'll never be more than 6 feet from an outlet.
I'm changing the single pole switch to a 3-way switch for the stairway light. in adding a second three-way switch for the light here in the family room.
The second switch will be located here at the entrance to the addition, with another three-way for the addition's switched receptacle. Now, the code and common sense tell you to locate the switches near the entrance to each room. By doing this, you'll always be able to enter and exit a room without fumbling around in the dark.
In the upstairs of the addition, we'll have soffit lighting running the full length of the walls on either side of the room. So we'll mark for a feed up here. We'll place a receptacle in the middle of our entertainment center at this point. And because we're remodeling our kitchen, we already have some existing circuits, so it's just a matter of rewiring to change the location of the outlets to suit the new design.
The new bathroom we'll be adding here in the basement has some special wiring requirements. The code requires at least one switched light source and at least one ground fault interrupter receptacle near the vanity to allow the safe use of a shaver or hair dryer. A ground fault interrupter, or GFI, is a device built into a receptacle that monitors the flow of current through that receptacle. When it detects a ground, like when you step out of the shower and plug in a defective hair dryer, the GFI quickly opens the circuit, shutting off the flow of current, and reduces the danger of electrical shock.
These are excellent safety devices, and the code requires their use in all outdoor receptacles, bathroom receptacles, and most garage receptacles. In our bathroom, we'll run 3 circuits. One 15-amp GFI circuit will run to the Whirlpool motor. Another 15-amp circuit will power the lighting and the fans. The third 15-amp circuit will feed the GFI receptacle here on the vanity. Here in the shop space, we're going to run 2 20-amp circuits to allow for the use of power tools. We'll use 12-3 Romex to carry the 2 circuits in on one cable.
The 2 circuits share the neutral wire, but the black wire is connected to one 20-amp breaker in the service panel, and the red wire is connected to another. At the service panel hookup, you want to make sure the breakers are not on the same power bus line. One goes on A and the other on B.
We'll run our 12-3 cable to the workbench, and then we'll wire 2 receptacles on this wall on the black feed and 2 receptacles on this wall on the red feed. So now I can plug my power miter saw in on one circuit and any other power tool I might want to use on the other.
Now, there are existing circuits here in the unfinished basement, and we'll be using those for lighting. But we're also going to be adding an additional 15-amp circuit to provide receptacles for the bedroom, the playroom, and a study. And here, we'll be going outside to add an outdoor receptacle, and we'll be using a GFI receptacle to comply with code. If you have existing receptacles in a garage, outdoors, or in a bathroom that aren't protected by a GFI device, well, this is an easy improvement that will make your home safer. Now, as always, I've turned off the power at the service panel and then checked to make sure the circuit is safe to work on. Now, here on this cement floor, I like to stand on a board so I'm insulated from the ground. The GFI receptacle is wired just like any other receptacle is. Just make sure that the neutral wire is connected to the silver terminal and the hot wire is connected to the brass-colored terminal.
All right, let's review what happened during the rough-in. The Romex runs from the service panel in the garage and enters the basement here. 7 circuits supply power for all the rooms in the lower level. Each of the 7 circuits enters through these 4 wires. Starting with the shop, we supply our 220 amp circuits using 12-3 Romex and multi-wired for the 4 receptacles. After the rough-in inspection, we'll install surface raceway on this 20 amp circuit and another on this 20 amp circuit. The 6th circuit, also 15 amp, supplies the new wall receptacles we've installed around the perimeter. Again, the overhead light is run by the existing 15 amp circuit.
The 7th and last 15 amp circuit supplies the power here in the new addition. Now, because there's no overhead light in our design, we've added 2 switches, one for a switch receptacle and the other for the closet light.
And we've added an A circuit to feed the upstairs of our new addition.
Now here's one last tip. Plan for and run your TV's coaxial cable and or your phone line at the same time you run your electrical, and you'll avoid some extra work later on down the line. Well, that's it.
We hope we've given you an idea of what's involved in wiring a house, so your next electrical project will be a little easier. I'm Dean Johnson.
And I'm Peggy Knapp. So long.
Hometime is made possible by Chevrolet, who brings you full-size Chevy pickups, the most advanced in Chevy history. Chevy S10 pickups, compact, fun, and hard-working. Chevy S10 Blazer, America's most popular sport utility vehicle. Chevy Astro, the van that can. The heartbeat of America. Today's Chevy truck.